solve it mathematically is I'm going to undo my addition by subtraction. So 18 minus 18 is 0. And since I did it to this half of the equation, I have to do it to this half of the equation. So I'm going to subtract 18 from there. And if I did my math right, it's 7. So in the end, you have x equals 7. So you can plug it back in and say 7 plus 18 is 25. Yes, that's the right answer. So in the same format, we're going to do multiplication and division now. And those are reciprocals. Reciprocal meaning kind of the opposite. Reciprocal. And if I have 5 times x equals 25, you probably know that x is 5, because you know 5 times 5 is 25. But the way I'm going to solve it mathematically is I'm going to divide. So I'm going to undo my multiplication with division, because 5 divided by 5 is the big one, right? So it's now x has been isolated, and since I did it on this side of the equation, the division, I have to do it on this side of the equation. And 25 divided by 5 is 5. So indeed, x is 25. So this is pre-algebra, and now we're going to move on to question 84 and talk about Margaret's enlarging a diagram for her poster. So she has this table that has the original width of her graph, original, and she's going to call this R. I guess she's taking the R out of original. And she's going to enlarge it to put on a poster about 36 inches wide, so about this wide. So she has a 1 inch, 2 inch, 3 inch width of a graph. And when it gets enlarged, we're told that it's going to be 5 inches now, if you enlarge it maybe on the copy machine. If you enlarge it, the 2 inch one, it's going to jump to 10. And if you enlarge the 3 inch one, it's going to jump to 15. So hopefully you can see the pattern that's developing here. I multiplied this by 5 to get a 5 inch enlargement. I multiplied this by 5. So the machine must be enlarging by 5s. So the question in A says, help Margaret by writing an expression that represents the width of the enlarged diagram if her original diagram is R inches wide. So both of these are in inches. So we're going to say our expression is going to be 5 times R equals, oh, we don't need an equals yet because it's just an expression. So this is the expression that relates the enlarged diagram if her original was R. That's the enlarged, 5R. So B says, now write and solve an equation to determine the widest diagram that she can use by enlarging these on her machine by 5 to still fit on the poster paper if she positions her paper so that it's 36 inches across. So all I'm going to do is I'm going to take my enlarged and I say it's going to equal to 36. This is my maximum allowed width. And I'm going to do the reciprocal to undo it. So to undo multiplication, I'm going to divide. So R is going to equal 36 divided by 5, whatever that number is. It doesn't go in evenly. There's no 5 and 36 that have the same factor. So we can leave it at that, or we can divide it out. That would be fine. Maybe we should divide it out and see what kind of decimal we get for that fraction. So 5 goes into 36 7 times. 7 times 5 is 35. And we have a 1 left over. We're going to bring down the 0. And then we're going to say 5 goes into 10 twice. So this is my decimal representation in inches of this ratio or fraction, however you want to call that. C says, using another equation, what is the longest diagram that she can use to still fit the paper if she positions it so it's 48 inches wide? So instead of 36, we're going to do 48. Same equation and same steps. The same enlargement ratio. 5 times the original is going to have to equal 48 or less. So the largest thing she can have is 48 divided by 5, which I'll do that right here, is 5 goes into 48, 9 times, 3 left over, bring down to 0, 9.6 inches. So if she gets her paper, if this is 36 inches, she gets another 12 inches out here, she can have her original be 9.6, her original table, before she puts it on the enlargement machine. Okay? Okay, 2 more. 85. Raymond took Margaret's enlarged posters, and now he's going to reduce them. So she made her poster, and he's going to reduce it. It says by a multiplier of 1/6. So they fit into a tiny pocket reference book. They don't tell us which multiplier of 6. So we could do 1/6. We could do, this is kind of a strange, vague CPM question, which we're familiar with. So we have our original, and we could either multiply it by a 6. We could multiply it by 2/6, which is the third. We could multiply it by 3/6, which is a half, and so on. 4/6, 5/6. I think he probably wouldn't say a multiplier of 6, however, if it was 2/6 or 3/6, because he would say that was a multiplier of 3, a third, or a multiplier of a half. So I don't see, it just seems perfectly random to me. So I think we'll just stick with 1/3 being our multiplier in this problem. So we want to make a table that shows the width of her original. So we have original, which is R, and we have Raymond's reduction, which is 1/6 R. So if it was 1 inch, 2 inch, 3 inch, you would have 1 times a 6, which is 1/6. You would have 2 times a 6, which is 1/3. We're getting a little bit bigger. And 3 times a 6, which is 1/2. So in his small book that he has, or is it a poster? Is it a book? It's a little book. It's cute. He's gonna have her 1 inch graph is now gonna be a tiny little 1/6 inch graph. And her 2 inch graph, which is a little bit bigger than a 1 inch, twice the size, is gonna be twice the size of that. Yeah. So bigger. And then this 3 inch one, it's pretty big for 3 inches, is going to be a 1/2 inch book. Cute. Okay, so we have our expression. There's our expression. We have our table. Raymond's book is only 4 inches wide. Here we go. Write an equation to determine the widest diagram that her original can be to still fit in a 4 inch book. So we're going to take one, maybe I'll write that in a different color. We're going to take our equation. I guess if I reach up, you can't see. Well, you can see. 1/6 R equals 4 inches. So to get rid of this multiplier, I'm going to multiply by the reciprocal. Because if I multiply 1/6 by 6/1, these go away. I'm just left with 1. So since I multiplied that side by 6 over 1, I need to multiply that side by 6/1. And I get R is 24 inches. Woo. So she can have a 24 inch table and still fit in his 4 inch book. Oh no, it should be 4 inches over here, sorry. Because his table ends up being, his book ends up being a lot bigger than that. So she can have a 24 inch table to fit in his 4 inch book. Solve your equation to determine the widest. Explain how you solved. Okay, so we did that. Last one today is Carolyn is helping her dad buy screws so they can lay new wood flooring. At the hardware store, Carolyn sees the graph at right posted on the store wall. So let's enlarge that so my old eyes can see this. So we have on the y-axis, we have the number of screws, I guess in a box, and how many you need to do this much flooring. So this dot right here, This is the X number quantity. You can do 1,000 square feet, which is right here between the 8 and the 12. And you will need to buy 600 screws. So that's what this linear straight line graph is trying to show us at the hardware store. So first we want to write an expression for the number of screws Carolyn needs for any number of square feet. Use a fraction, not a decimal, in your expression. So we have to look and see if we can figure out what the pattern is. Let me erase this. Or maybe I'll just do it on here. If we want the expression for number of screws for square feet. So we have 600, I will do it on here. It shows up better, the black or the red, I can't decide. So we have how many screws for square feet of flooring? And we're looking on that graph and it's saying that we need 600 screws for 1,000 square feet. So if we want to find out the number of, we want an expression for the number of screws for the flooring. So I think we can do this a couple different ways, but I think the way that makes the most sense is to have the number of screws per 1 square foot. So I want to have a 1 over here on this side of the equation. So I'm going to divide each side by 1,000. So now I have 1 square foot over there. Divide this by 1,000. Those two. Now I have 6/10. Does it say do it a fraction or a decimal? Use a fraction, not a decimal. 6/10 screws for every square foot. And hopefully you see that you can actually reduce 6/10. This is the same answer. Let's put S for square foot. Or screw. So here we have our expression for the number of screws. Technically, if it's just an expression, it doesn't have an equal sign in it. But that's our expression for number of screws per square foot. So she already has 250 screws at her house. Cool. Right? And did they tell us how many square feet? Write and solve an equation to determine how much flooring she can lay with the screws she already has. Oh, without buying any. Interesting. So she wants to see how many she can use just with what they already have at home. So she has 250 screws. 3/5 screws. So we want to set that equal to, that's the number of screws. So this is the number of screws you need for 1 square foot. And she has 250 screws. So to isolate screws on one side, let's do it up here so you can see it a little better. 3/5 screws equals 1 square foot, 250 screws. So I'm going to isolate that on the left side of the equation, and I'm going to multiply this by 5/3 to make it go away to 1. As I multiplied it by 5/3 on that side, I'm going to multiply it by 5/3 on that side. And that she can do about 416 square feet. With 250 screws, will get you 416 square feet done with nailing it into the floor. Okay, so I know that was a lot today, and thanks for sticking with me, and I'll see you next time. Bye.